My name again is Sika Besa Funyefia, popularly called Professor or Prof. Sika. I actually come out with this initiative on based on the coronavirus outbreak or the COVID-19 pandemic. I realized a lot of students or a lot of SHS students and students from other centers of learning are in their various houses since all the schools have been closed down in order to avoid further spread of the disease. I am someone who always believe that in every opportunity or in every adversity or in every situation there is an opportunity. Though I'm not trying to say I'm taking an advantage of the situation, it can be no, but as a way of helping brothers and sisters to continue their learning process. Learning is something that once you start, you cannot stop. We learn every day. We learn formally or and that of what? The informal way. So learning doesn't stop. You only stop learning when you die. When you die, you stop learning. That is it. Okay, now to continue. I'm a professional teacher. I've been trained as a teacher from Beto University of Education, Winneba, Kumasi campus from 2012 to 2016, where I pursue Bachelor of Science Accounting Education. So I'm here to take you through core mathematics. And apart from being a teacher, though I'm no longer in the formal teaching sector, I'm no longer working for anyone. I work for myself. Yes, I'm a researcher, and I'm also an author. I write books. As you can see, this is the first book I have written so far. It's a storybook that I have written. I wrote this book, though the idea came in mind, that was 2017. So I wrote the book just this year, 2020. So this is the first book I've written, and the title is The Broad and Narrow Ways, or The Three Racketeers. The Broad and Narrow Ways. This is the first book I've written. And those who are on my WhatsApp platform, you already know much about me. This is me. Most of you have never seen before, but some of you too, you were once my students, so you knew me, you know the kind of person I am. Yes, this is me, the Sika Besa Funyefia, popularly called Professor. And the initiative that I came out with is titled Sika Education Publishing Sika Education Research Publishing and Consultancy, which I abbreviate it as SEPS, as you can see on the board. So SEPS, Sika Education Research Publishing and Consultancy, as you can see on the board, SEPS. That is the initiative. This initiative, we are into online teaching. We are also into research. I'm also into publishing. Publishing deals with writing books and then letting it out to the market for potential and existing buyers to buy, read it, or to buy for their consumption. When I say I mean used. So that is it. Now, I'm also writing an additional two books. I write books based on situations. I write books to address situations or to solve problems or to be able to fine tune measures in order to combat or improve a particular phenomena. These are instances whereby I write books. So these are some of the inspirations that makes me to write. I don't just get up and start writing. I write by inspiration. I write by having that kind of divine ideas or divine inspiration, because I'm somebody. I also believe in spirituality. I believe in the existence of the Almighty God, and anything I do it in accordance to the religion I belong to. So that is the kind of person I am. Now, to continue, I've realized that uh, in our daily life, mathematics is we do mathematics in our daily life. We work mathematics, we talk mathematics, and everything we do is mathematics. Even the way we eat is mathematics. Once we cannot do away with figures, we can also do away with mathematics. Once we cannot do away with situations that can sometimes be quantified or put in a qualitative manner, then we cannot do away with mathematics. And also, I've also realized that though a lot of students, they have had that kind of contact with their peers or teachers or other tutors on a particular topic that we are coming to do today. And this topic is not purposely for exams, though it's an examinable topic. No matter what, they set questions on it. However, apart from it being a topic that normally comes in exam, we also practice it in our daily life. So that brings the idea to start with this very topic. And before I continue, all my lessons are on my YouTube channel, which is SEPS. If you type SEPS Prof. Sika, that's my YouTube channel. SEPS Prof. Sika. That's the name of my YouTube channel. Okay. Now, when object comes into or when we have a flat surface, every flat surface normally contains something we call dimensions. Like this flat surface, well, as I'm standing on it, myself, I'm more or less a dimension on this flat surface. On this very flat surface here, we have a lot of things we put on it, so it's a dimension. That's why I say mass, we cannot do away with mass, because even the land, which we consider as a flat surface, we work on it, we build on it, we do a lot of things on the land. So so this particular flat surface, which flat surface within which dimensions come into contact with or meet, we call it plane. 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 Now, there are a situation whereby, in our daily life or activities, we deal with size. How big is something? How small is it? We deal with those things. We deal with what? Shape. We also deal with volume. When I'm talking about volume, I mean the amount of commodity or items or liquid substance, either liquid or solid substance, that an object can contain. That's the volume I mean. So we carry loads with our head pan, we carry loads with our bowls. Even I fill water, or this particular bottle contains what? Water. So the amount of water it contains, that is what we refer to as what? Volume. So you see, mass, you cannot do away with mass. So that is what volume. That's its volume. Its capacity to hold that water, it becomes its volume. Not objects also have the capacity to hold what? Solid, not only what water. Because I can pour this water out and fill it with what? Sugar or any solid or substance that can enter or go into it. So a situation whereby we try to study those things, we try to study the size, we try to study the volumes, we try to study size, volumes, the surface area. When we any situation whereby we try to learn those things or we try to study them, we refer to them as what? Geometry. Geometry. So today our main topic is plane geometry. Meaning a situation whereby shapes, size, volumes, surface area, and others come into contact with what? Flat surface. That's what we mean by plane geometry. So under plane geometry, we also have a lot of things under plane geometry, as I've stated. Volume, shapes, and all stuff. So we are coming to look at a particular point under this plane geometry, or a particular subtopic under this plane geometry. You see, anytime you try to do some measurement, maybe when you want to put up a house, you have to measure, you have to construct, you have to deal with what the area, measure the area. You have to also measure the how to put out the concrete. So you make a lot of measurements. Now those measurements, you don't just measure it haphazardly or measure it anyhow. You make sure you have your accurate measurement. Now also, before you erect your pillars, you have to do some measurements. So you move from point to point, from this place to this place, and it follow in what dimension. Normally we will use straight lines. Good. Now, apart from that, so now sometimes when you use the pillars, you try to what? Turn. You make some turn. Apart from that, as I'm standing here, talking, I am making turns. How? With my arms. Because I'm using my arms to hold these things, to hold the equation, to hold the markers. So I'm making a turn. So a situation whereby I try to make turns with my arms, or we try to do some measurement to calculate the amount of turns that we made on a flat surface. Whenever we place an object on the land or an object on the flat surface, that object can be in a horizontal or in what? Vertical. So when we try to measure the turns of that object, we refer to them as what? Angles. So today we are coming to look at angles. Angles. I have even said a lot about it already. Angles. As you can see on the board. Angles. Okay. Now, the question is, so today, by the end of today's lesson, we should be able to get the meaning of angles. Or how do you explain to a layman angle? We should also be able to know or get to know or to identify parts of an angle. We should be able to also identify or identify the various types of what? Angles. They are formulas. How do we calculate them, those types of angles, when we come into contact with them in our daily life or in our endeavors? So these are the things we'll be looking at today. To begin with, the definition of angle. What is angle, or what are angles? My subtopic is angle, not angles. Now, some scholars says that is from the ancient how this plane geometry came into being. According to them, they says that an angle is the measurement of rays, or is the measurement in which rays come into contact with, or in which rays meet a plane. Is a measurement in which, or is a measurement by which rays, or is a measurement of rays meeting what? A plane. That's one perspective of an angle. You try to measure when rays meet a plane. When I say when rays meet a plane, maybe I want to the ray here I'm talking about the size. the size, the length. I want to come out with my building. So I punch a hole here. I try to put my measurement here, one measurement here, label here as well, maybe the first pillar. I put another measurement here. This is the second pillar. Then I join this one. Now, I put another measurement here. This is a third pillar. I join this one. What did you see? So you realize that from here to here is a ray. Then from here to here is a ray. So you realize that two rays meet on a plane surface at a point. So when we try to measure the times at which two rays meet at a point on a plane, that measurement is what we call angle. So we can now say that angle is the measurement of the amount for which two rays meet on a plane at a point, because they must meet at a point, and this is the point here, the 10. So when you try to measure the tens, that is what we call angles. So this ray and then this ray, they come to meet at a point. Then you try to measure it, the tens. When I say the 10, you try to measure here, that's the 10. You try to measure between the two rays that meet at a point. So trying to measure between the two rays meeting at a point on a plane is what we call angles. So an angle is the measurement of, or is the amount of, or is the measurement of the, is the measurement of, or is the measurement between two rays that meeting on a plane at a point. Okay, so we'll try to put down that definition. So it is the measurement between two rays that meet on a plane at a point. That is what? Angle. The definition. So angle. Okay, so that's the first definition. Now let's look at another perspective. So even if you have forgotten, just when they ask you what is an angle, or you want to explain to a child or someone who doesn't know what an angle is, try to picture. Let's say I want to put up a house. What do I do? First of all, I have to measure. After clearing my space, filling the space, making it a flat. I have to look for what? I have to start my measurement by getting a point. So that's the first point. Then I will measure it straight to another point. Then from there, I have to turn and measure to the next point. So where I turn, you create a point there. So meaning you are looking at the first line and then the second line. So the first line and the second line, they meet at a point. That's the ray. So where they meet, the point at which they meet, then you have to measure between them. Measuring between them here becomes what? Your angle. So the measurement between them, that's the angle. The value that you obtain when you measure between these two rays becomes your angle. So that is it. Okay, now let's look at the other definition or the other perspective. I said earlier that as I'm standing here, when I move my arms, an angle is formed. But if I didn't move my arms, no angle has been formed. So right now, if I move my arm this way, meaning I've turned my arm, because this is an arm, this is an arm. So as soon as I turn it, angles form. Okay, so that is it. When I turn my arms, an angle form. So what then is an angle with respect to the arms? We said an angle is formed when two arms, or an angle is formed when arms turns. An angle is formed when arms turn. So as soon as I turn my arm, an angle is formed. So trying to measure the amount of what? Arms turns, or trying to measure the amount of turns of for arms becomes an angle. So an angle So that's what I've written here. An angle is formed when arms turn. The measurement of the amount of turns between arms is angle. I have my arms this way. The moment I turn my arms, an angle is formed. When I turn my arms this way, an angle is formed. Now, take note. Angle doesn't form on only one ray. No. Before an angle is formed, it must be between two. It must be between what? Two rays, or the arms, the two arms. Even if I straighten my arms this way, an angle is formed between here. So I have to look at the point here. This is the turning point. So this is where the angle forms. So when I try to measure the turns, it becomes what? That value I will obtain is the angle. So let's take note of that. Okay. Now let's look at, so for you to get a picture, you can draw something here as point A, point B, point C. Yeah, this is what? Angle. So you can draw something like this, just to remember. Or when we have something like this is the 10. This becomes angle. So you can, just to remember it easily. So that is for the definition of an angle. Now let's look at, so you can copy it. Okay. Now let's look at powers of angle. Powers of angle. Now we know that before the angle, those plane geometry, it started in the olden days with this Latin. It started in Latin. That is under the Euclides Alexandra. Before later on it was developed, it passed a lot of developmental stages to Albert Einstein. So the angle is from a Latin word called angulus. 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 That's the Latin word for angle. And it means, in Latin, it means corner or crook. When we say angulus in Latin, it's corner or crook or crook. Corner or crook. Now let's look at parts of angle. parts of angle. I will say it and then draw it and label the part. That's all. The distance between all the rays, are known as what? The size. For an angle, the rays, like the straight lines, they are called size. Now the corner in which two rays meet or two arms turn is what we call vertex. We call it vertex. So when I draw this, this is a ray. This one is a ray. This particular point here is what? Vertex. So let me clean these ones instead. So this is vertex. V-E-R-T-E-X. Vertex. This is a ray. So this one is a ray. This one is a vertex. So let's take. So these are parts of what? Angles. Take note of this. Now let's look at types of angles. Types of angles. Types of angles. Note that types of angles. Let's take note of something. Anytime the angles increases, the name, whether anytime angles increases or decreases, the names what? Changes. When an angle either it increase or it decrease, the name changes, depending on where you are starting from. The name changes. But in most of the books, they will tell you that the angles, the name changes when they increases, depending on where you are coming from, or the perspective from which you are drawing your conclusion. So note. The names of an angle changes when it increases. It increases or decreases. Because if I'm starting from a straight line, if I'm starting from this, it's an angle. This is the point. It's an angle. Maybe I start from this, then I move to this. What happened? This one has decreased to this. So I can prove my point here. Alright. So let's take note of this. Now we have so many types of angles. First, when I move my arm this way, you see that I'll be feeling some kind of discomfort, and it's very small. This is very small. So I'm feeling some kind of discomfort. So in English, when we are feeling discomfort, as a result of certain positions or phenomena, we refer to it as what? Acute. So when I make my arms this way, I classify it under angle. This is an angle that has been formed because when arms turn. So this is what we call acute angle, because when I turn my arm this way, I'm feeling some kind of discomfort. So that's how come by the word acute. So at this acute angle. So what then is an acute angle? It is an angle formed below 90 degrees. Take note, every angle is more than 0. Angles are more than 0. There must be a number. When an angle formed, there must be a number or a value. So angles are, it can be 0.0001, it's still an angle, but not 0 itself. So let's take note of that. So acute angle it's an angle formed below 90 degrees. That's acute angles. So let me draw the acute angle. When I position my arm this way, so I have this, or I have this. This is acute angle. Now, acute angles are more than 0, but they are below 90 degrees. So we say we come out with this formula: 0 less than x, where x is the angle, which can be a number. You can reduce this. So where x is the number, where x is the number. So x, this number here, meaning, oh, you can continue. So this number here, it can be 0, it can be 1, it can be 2, it can be 0.001. Now, so that number must be more than 0, meaning 0 is less than that number. And the same number must also be what? That angle must also be less than 90 degrees. So this is how come by this formula or this statement for acute angle, because they are more than 0. Is any number, any angle formed below more than, which is more than 0, but it is lower than what? 90 degrees. That is an acute angle. So let's take note of that. So when I position my arms this way, acute angle is being formed. Now when I increase it this way, you realize that this one I'm very comfortable with it. And when you look at it, this particular arm is horizontal, and this one too is what? Vertical. So this way, with it becomes what? 90. This is actually 90 degrees. So this kind of angle is what we call right angle. So we call it right angle. So right angle, it is an angle formed at 90 degrees. And if you see the symbol, so this is a symbol for right angle. So if I draw something like this, and I put that symbol, you should know that I'm dealing with 190. That's 90 degrees. So this is the 90 degrees, specifying it to be right angle. So we said right angle normally, yeah, we can say 0 less than x equal to 90, which is 90 degrees. So I can say now acute angle is what? 90 degrees. So let's take note of this. So that is a right angle. Then we'll be looking at the next one. As I move my arms this way, this is a right angle that has been formed. When I move my arms this way, another angle is being formed. This one is more than 90 degrees, but it's less than 180 degrees. So this one we call it obtuse angle. Obtuse angle. So that is obtuse angle. So it is an angle formed more than 90 degrees, but less than 180 degrees. You know, 180 is a straight line. When you have a straight line this way, if you are using a compass and others to your other construction materials to draw, when you sketch it, if you sketch a straight line and you measure it with protractor, you get 90 degrees. You get 180. So this one, I've moved my arm this way, so it's not yet straight. So you can't say it's 180. So that's why we say well, but it's more than 90 because this is 90 and I move it small. It becomes more greater than 90, but it's less than 180. So that is what obtuse angle. So it is an angle formed above 90 degrees but below 180 degrees. Or it is an angle which is less than 90, which is more than 90 degrees, or but less than 180 degrees. So I can draw something. So obtuse angles normally more than 90. So we say 90 degrees less than a number or the angle. And this same angle is also less than 180. 90 less than, meaning the number is more than 90. And this same number is also less than 180. So it can be 95 degrees, 100 degrees, 120 degrees, or 90.001 degrees. But it will not be up to 180 degrees. So this particular angle is what we call obtuse angle. Now, after moving my arm this way, when I make my arm straight this way, I get some horizontal line, either horizontal or vertical, depending on the position. As I move, I stretch my arm straight. It forms another angle. And this one is 180. When you measure it, if you use protractor to measure, it's 180. This angle is what we call angle on a straight line. Angle on a straight line. Not angle, so angle on a straight line. So angle on a straight line, it is an angle formed at 180 degrees. We have another name for angle on a straight line. So please, when you go and look for the other name for angle on a straight line, in our next meeting, we'll try to discuss it or elaborate on it. Angle on a straight line. So if I have this, this is what angle on a straight line. When I make my arms straight, it gives me angle on a straight line. Okay. So now I've straightened my arms. Now let's say because as I straighten my arm this way, I cannot move it anyhow. So let's say my hand touches fire without maybe I didn't plan for it. Or as I'm here, I try to touch this charger, then I get electric shock. What will happen? When that incident happens, meaning I didn't prepare, so it became involuntary. So I may also turn my arm this way. When I turn my arm this way, meaning I try to respond to that stimulus. I try to respond to that action. So turning my arm this way is a response to that action. You see that my arms are turned this way because you cannot. Your normal thing, you can't just turn your arm this way without any cause for it. So as I turn my arm this way, listeners or viewers, I'm very sorry for the sound at the background, but just pay attention to whatever I'm saying. So when I turn my arms this way, an angle is formed, and that meaning I'm trying to respond to that stimulus in unconscious manner. And anytime you respond to a stimulus in an unconscious manner, we refer to it as a reflex. That's reflex action. So when you turn your arm this way, the angle that is formed there, we call it reflex angle. Because it's like a reflex action. The angle is formed maybe based on a reflex action, or because of those circumstances that leads to the turning of the arm to that direction. That's why they refer to it as what? Reflex angle. So reflex angle, you can see that it's more than 180, less than 360. So reflex angle, it is an angle formed above 180 degrees, but below 360 degrees.